Hello everyone. In this video, I would like to revise our concept, and also the previous normalization process according to the precise definition of various kinds of keys. Okay. In the previous examples, to simplify the demonstration, we simply focus on the primary key. Okay, and the functional dependencies. However, this is not the precise way or the correct way. So today I would like to use this video to demonstrate the more proper approach. Before that, I would like to add the attribute called ID. It's similar to the row ID in SQLite. That means whenever we insert a row into the table, an integer ID is automatically generated, so it is proper as a primary key. So before we go through the normalization process, let's define various kinds of keys. The first one is super key. Basically, in a table, any combination of the attributes that can be uniquely identify a row is a super key. So, for example, ID is a super key. The serial number and timestamp is super key. Or all the attributes forms a super key of this table. The fourth example is the attributes that do not contain the category and category description. So all the four kinds of combinations are proper as the super keys. The next one is composite key. A composite key is similar to the definition of composite attribute. So it's a key. However, it contains more than one attribute. So the definition is simple. The next one is candidate key. A candidate key is very important. Candidate key is a key. Maybe it's a single value key or a composite key. To be a composite candidate key, all the attributes in the key are required. That means whenever we remove one of the attributes from the candidate key, the remaining attributes cannot serve as a key. So candidate key, in our example, there are two candidate keys. One is a single value candidate key, ID, and the other is the composite key, serial number and timestamp. So remember, candidate key is you may think that it's a required set of attributes that can be used as a key. So whenever we remove any one of the attribute from the attribute set, the collection of the set of attributes becomes a non-key attribute. So the next one is primary key. Primary key is one of the candidate keys. So we choose the primary key from the candidate keys. Given the table, there should be a primary key, and may have more than one candidate keys. So depending on its candidate key or primary key, there are non-key attribute or non-prime attribute. For non-key attribute, that means the attribute is not included in any of the candidate keys. For non-prime attribute, that means it's an attribute that is not part of the primary key. So based on the definition of the keys, now let's start the normalization process. Okay. Again, okay, according to the new table design. Okay. And I think that this time we will focus on the candidate key, okay, candidate keys, right, instead of the primary keys. Okay, so according to the definition, ID is the primary key, so it is used for determining all the other attributes. And this is the first normal form table. To make it second normal form, we need to determine the partial dependencies. However, according to the primary key, it's a single value, so there is no partial dependency, okay, in the primary key. Okay, but okay, the precise definition of partial dependency is related to candidate keys. Okay, so to find out the partial dependency, we need to examine, okay, all the partial attributes, okay, all the partial combination of the candidate keys to identify the partial dependency. So serial number and timestamp is the candidate key, and we learned that timestamp can be used for determining the description, amount, and place. So this is a partial dependency. And according to the normalization process we learned, we need to decompose the first normal form table. Okay. So the partial dependency becomes a standalone table. So the primary key is TS. It is used for determining description, amount, and place. And then the remaining attributes, ID, serial number, timestamp, okay, and category description. Okay, ID is the primary key to determine all the others. Okay, so this is the second normal form design. In the second normal form design, we learned that category can be used for determining category description. So this is a transitive dependency. And again, let's revise our concept that the so-called non-key attribute, okay, non-key attribute is related to the candidate key, not the primary key only. Okay, so we further decompose this table into two tables. Okay, ID, serial number, timestamp, category. Okay, and category description. Okay, it's a standalone table. Okay, so this is the third normal form design. Okay, so the definition of candidate key, primary key, and the definition of partial dependency and non-key attribute, or the transitive dependency, okay, are related to candidate keys. Okay, in the end, I would like to talk about the foreign key. Foreign key is in a relational model is the referential constraint. You could see that in the category, in the table, category refers to the primary key to the category table. So the category value, the value of this attribute should be exist, or should be a valid value that can be used in the category table. So this is an additional constraint, and the category attribute in the ID serial number timestamp table is called foreign key. It's foreign key. It refers to the primary key in the other table, and this is a referential constraint. For the details, please read the textbook, and you will see that there are some rules related to this constraint. Okay, so please remember that candidate key and functional dependencies analysis